calculator crazy on you. There is a checkpoint for law of sines and law of cosines we will get to as soon as we finish these notes. Toby doesn't even have to solve for x on the checkpoint. The checkpoint says, can you set up these two problems? All I need to know is, can Toby set up a law of sines problem? Can Toby set up a law of cosines problem? On the checkpoint, I even put LOS, meaning law of sines, LOC, meaning law of cosines. On the test, I will also designate, like 5 through 17, use law of cosines. There's no way Toby won't know when I want it. But of course, we're going to discuss when he actually needs it in life as well. Okay, remind me of the distance formula.
X squared, no, x 2 minus x1 squared. Y2 minus y1 squared.
Get it together. I don't have time to basic today. My God. Oh my God. Say it again, Trey. I was too busy focused on Giggle Monster. Yeah, you said something. I don't know what you said. No, you're trying to think midpoint. You're trying to merge distance and midpoint together. Okay, so we also learned a trick to this that involved counting, but we're not doing that today. We're just going to focus on plugging and checking. So if Danny can come up with this formula, everything else should be pretty easy. She can call this one x1, y1. She can call this x2, y2. It doesn't matter as long as she leaves the 1's together and the 2's together. Okay, so x2 would be 12, so 12 minus 6 squared plus 8 minus negative 2 squared. What is 12 minus 6? So I have 6 squared, and then 8 minus negative 2? 10 squared. So I end up having 36 plus 100, which is 136. Should I stop there? Can we simplify that radical? We can. What times what is 136? That's 2 is one of them, but 2 is not a perfect square. Pick a perfect square. 4 and what? 4 and 6 is 30. 24. 4 times 6 is 24. 4 and what? 64? Yes, thank you for someone with a calculator. Okay, so we end up getting 2 square roots of 34. If Katie can't do the last little bit here on the ACT, she can at least do decimal match, which one of the answer choices matches decimal wise. As long as she can get to here, she can figure out the rest. Okay, so we've got to get back to the laws of sines and cosines. What I didn't say yesterday that I should have said is notice that, oh my God. It's not your group. They can't get it together, Isaac. It's not your group.
Is it my group?
No. Your group's just zoned out. That's fine. That I can do. It's the Giggle Monster group I can't do. Notice law of sines and law of cosines. All non-right triangles. First time in forever we've done something that's not a right triangle. So, moral of the story being, if Danny ever sees something on the ACT that's a right triangle, she should try the tricks we've been using. She should try Pythagorean theorem. She could try something with Sakatoa. Right triangles are easier to solve. It's when we get this complicated non-right triangle that we have to pull out some laws, like the law of sines and the law of cosines. Yesterday we made a list of when to use the law of sines, but really the moral of the story was if you could find circle buddies, you could use the law of sines. I found 2 pairs of circle buddies, therefore I used the law of sines. On the back, on the law of cosines, we have to use the law of cosines because there's only one circle buddy. That's when I know how to use the law of cosines. If I can't find 2 circle buddies, I can't use the law of sines. I have to use the law of cosines. Now, if you want the math technical answer of when the law of cosines is supposed to be used, it's supposed to be used for SSS, meaning you're given the three sides. And it's supposed to be used for SAS, which you know that means two sides and the included angle. But again, do I expect Alex to remember that? No. All Alex has to do is try circle buddies. If he fails, he needs the law of cosines. Okay, so there are three versions to this bad boy, which you will learn about in Algebra 2 of the trig. But for me, we're only going to do one version. It's a squared equals b squared plus c squared minus 2bc cosine of a. You know the tiny letters mean sides. You know the big letter means it's an angle. We're either going to be missing a side, and we're going to plug it in for little a, or we're going to be missing an angle, and we're going to plug it in for big A. Those are our two options for today. Okay, just like yesterday, there's no feasible amount of time or enough space on the notes for us to work all of these problems. So as soon as I think those who are listening are good, I'm going to move on. Okay, so I started my first one. I'm going to start at number 1. I'm going to go ahead and write that formula. I'm missing a side. So I get to plug that in for little a. So I'm going to have x squared equals, b and c do not matter. It does not matter if you pick 9 for b or 11 for b. So I'll have 9 squared plus 11 squared minus 2 times b I picked a 9, c I picked 11, cosine of my angle is 28 degrees. Okay, let's pretend this is a 5-point test question. Sydney's at 3 out of 5 for merely plugging in the stuff into the formula correctly. Her 4th point is for trying to solve. Her 5th point is for reaching the right answer. Okay, now I can pick on Tori because she shows her work. Okay, Tori is actually going to solve this out like most of us should. So 9 squared, that's 81. What's 11 squared? Okay, and then I need to know 2 times 9 times 11. 198 cosine of 28. Okay, and then I have some like terms that I can combine. So I can add 81 and 121, and I'll have x squared equals, I don't know what that is, 202 minus 198 cosine of 28. Okay, here's where the first major mistake could happen for the day. Toby could think 202 minus 198 is 4 and write 4 cosine 28. You can't do that. This one doesn't have a cosine 28, so they're not like terms, so you can't put them together. You have to type in that entire line, the 202 minus 198 cosine 28, into your calculator. I got 27.176, so I'm going to say that's 27.18. And then, of course, your second mistake could happen here, because am I done? No, I have to take the square root of both sides. So your calculator remembers your decimal. My hint to you would be, you can press second square root, and then there's a second answer button, A and S, down near the bottom of your calculator, also in blue or whatever the second button colors are for you. When you press it, you end up getting 5.21. If we read the directions, it says tenth, so I'm going to put 5.2. So x equals 5.2. Okay, I did that quickly. Are there any questions about the calculator buttons or how I solved? Yes, dear. There should be a second answer button. Is yours in green? ANS should be, my ANS is down near the bottom. Yeah, mine's down here. It's in blue, but if your second button's in green, then it will be ANS in green. Better? Okay, we'll try another one. If you're still stuck, I'll look at it. Okay, so this is what Tori's going to do. And this is the right thing to do because she wants to get points from the math teacher for showing that she tried to solve her work. However, if Tori was lazy, and she's not, she could go back to that very top step right after we plugged everything in. She can type that entire line that I boxed in her calculator in one step. So she can do, let's see, 9 squared plus 11 squared minus 2 times 9 times 11 cosine 28 in one step. She still gets 27.18. She does second square root, second answer again. She still gets 5.2. Now, this is a lot faster. I'm totally with you. But if she happens to make a mistake, then I'm not going to see it because she doesn't turn in her calculator. She only turns in her work. Okay, are there any questions about number 1? Everyone found that second answer button? If you can't find it, you can do second square root and then type in the decimal again, 27.17, whatever. But then you see how it rounds a little differently? So there's potential for a little rounding error. It doesn't really matter to me today, but you know, in life that does make an impact. Okay, we're going to skip number 2. Oh, we're going to. We are going to skip number 4. Let's only do number 3. Okay, so again, I first see is there circle buddies. I have the one pair of circle buddies, but since there aren't 2 pairs of circle buddies, I can't use law of sines. Buddies. Yeah, buddies. Like 2 circle friends. Now, why that's what you thought was funny, I don't know. I didn't write another C there. Cosine of A. Okay, so again, I'm missing a side. So I get to put x squared equals, what should I put for the B? Okay, 7 squared. What should I put for the C then? 4 squared. Minus 2, what do I put? 7, 4, and then cosine of what? Okay, perfect. So again, Tilly has some options. She can take that entire line and from here type it in her calculator. So 7 squared plus 4 squared minus 2 times 7 times 4 cosine 62. Type the whole line in your calculator and you end up getting 38.7. There's nothing wrong with that. But I always like to show my work and make sure the teacher's giving me all my points. Plus I like doing fun math. So 49 plus 16. 28 times 2 is 56, minus 56 cosine 62. I can combine these two. So I get x squared equals 65 minus 56 cosine 62. 65 minus 56 cosine 62. Doesn't matter which way I did. So again, Grant can be lazy and type the entire line in his calculator. He'll get 38.7. Or Grant can show out his work, type in 65 minus 56 cosine 62, still get 38.7. It's just up to him. Again, if he's trying to get points for showing work, he obviously wants to do this way, but I completely understand why he just wants to type into the calculator. You know me, I would tell you to do both. But he's still not done. Even though he got x squared equals 38.71, He's got to take the square root of both sides to get the right answer. So second square root, second answer. What did you end up getting? I got 6.2. Okay, does anyone have any issues with this? Okay, why did I skip 2 and 4? They are the same. Why do I need to go to 5 through 8 now? What are they missing? The angle. So far, they're pretty nice. I don't mind law of cosines. It's plug and chug, really. I especially don't mind it when a side's missing. It's pretty easy. There's a little more work required when the angle's missing. So let's go to number 8 first. Are you wanting number 7? Did you want 7? Why 7? I was going to do 5. Will that satisfy you? Yeah. Okay. I am going to do a decimal one, but I'm going to go to the non-decimal one first. Okay, let's go to number 8. So I was going to try to use the law of sines. Didn't have enough circle buddies. Again, I've got to use that law of cosines. So a squared equals b squared plus c squared minus 2bc cosine of a. But I don't get to put the x in the a slot this time. I don't get to put the x in the a slot this time because I'm not missing that side. I'm missing the angle, so I know I get to put the x down here in the angle. It doesn't matter who you pick for B or C, but it does matter who you pick for A. What number do I need to put in the A slot? It has to be, which one?
5.
It's 5, 27, or 24. My hint to you would be circle buddy still helps. 24 goes with the side across from it. So I know that angle goes with the 24, so I'm going to do 24. So 24 squared equals, doesn't matter which one I pick, I'm going to do 5 squared plus 27 squared minus 2. 5 times 27 cosine of x. I'm out of room. Okay, there's no magic wonder where Sydney can type the whole line in her calculator and get the answer. Sydney knows how math class works. She's got to solve for x. So what's 24 squared?
576.
I know 5 squared is 25. What's 27 squared?
729.
I need to know 2 times 5 times 27.
270.
So I evaluated the 3 squares, and I did 2 times 5 times 27 to get 270. Are there any questions to hear? Well, I have some like terms I can combine. So I need to add 25 plus 729. Is it 754? That just sounded too small. Minus 270 cosine of x. Darn hole punch is getting in the way. X is still not by himself, so I've got to move that 754 over. I'm going to subtract 754 from both sides. What do you end up getting? 178? Okay. Okay, is x by itself? No. So, and I'm running out of room, sadly. I've got to get rid of that 270. So I'm going to divide both sides by negative 270. What did you end up getting when you divided negative 178 divided by negative 270?
0.65.
Okay, I got the 0.659 as well. I'm going to write out all 3 decimal places. So I have 0.659. You can't see because of that recording thing. So I have 0.659 equals, those canceled out, cosine x. Is x by himself?
No.
No. How do I kill off x? So I have to take cosine inverse of both sides. Cosine inverse of 0.659 is going to give me my value for x. So I'm going to press second cosine second answer. I got 48 point what? Did you get 48.75? So that's 48.8. Okay, so let me say all those words again. Sydney's getting 3 out of 5 points for can she plug the right stuff in the right spots into the law of cosines. She's getting her last 2 points from just attempting to solve, like the fact that I see she tried to use cosine inverse at some point. And the last point comes from did she solve correctly. I actually worked it out, combined like terms, subtracted them, divided by 270, took cosine inverse of both sides. I got 48.8. Now, most people don't like the law of cosine problems where the angles are missing, but they're my favorite because, back to any time the angle's missing, and it's a triangle, I know a reasonable answer is somewhere between 0 and 180. So when we got 48.8, I felt pretty good about it. If I got like 0.57, I don't feel good about that. I like answers that make me feel good, and I know I'm right or wrong. Okay, I am, for once in my life, going to pick the one with all the decimals. Let's go to number 5 and be brave. I tried to do circle bunnies. I failed. I had to resort to the law of cosines. So a squared equals b squared plus c squared minus 2bc cosine of a. What do I need to plug in for the a squared this time? Okay, so 1.9 squared equals, I'll do 1.3 for b. 1.3 squared plus 2.1 squared minus 2 times 1.3 times 2.1 cosine of x. So I need help with all these decimals. I need to know 1.9 squared. I know that one, but what's 2.1 squared? Now I need to know 2 times 1.3 times 2.1. Perfect. Again, I have some like terms I can combine on the right, so I need to add 1.69 and 4.41. Okay, so 3.61 equals 6.1 minus 5.46 cosine of x. I need to subtract 6.1 from both sides. What did you get? So I have negative 2.49 equals negative 5.46 cosine of x. Again, x is still not by himself, so I've got to divide both sides by negative 5.46. What did you get? I am going to put all 3 decimals. Is x by himself? No, so I've got to do cosine inverse of both sides. So cosine inverse of 0.456. That needs to give me my x. I got 62.86 as well, so I'm going to say 62.9 degrees equals x. Okay, again, and I'll move that in a second. Again, all my work is me showing how I'm rearranging the equation to get x by itself. Once you solve for x, you know your answer is reasonable because it's somewhere between 0 and 180. It looks like a realistic degree. So then you're done. That's all there is to the law of cosines in geometry, that is. That's all we're going to do with it. If you want to go back to your homework, you can. If you want to be brave and go ahead and take the checkpoint today rather than wait for tomorrow, I'm looking